Hi guys, we have been working very hard on our double stacks all week long. Today, we're going to continue to do that to build our fluency. Let's go ahead and do a quick review of our doubles that we learned. 1 plus 1 equals 2. 2 plus 2 equals 4. 3 plus 3 equals 6. 4 plus 4 equals 8. 5 plus 5 equals 10. Do them with me now. 6 plus 6 equals 12. 7 plus 7 equals 14. 8 plus 8 equals 16. 9 plus 9 equals 18. 10 plus 10 equals 20. We have been doing so well with memorizing our facts. We're going to do a quick review with our video friends. They're going to help us remember our doubles facts as we get into our story problems today. I'm going to go ahead and share with you our learning target. Our learning target today is, I can use doubles facts to solve story problems. We are going to be reviewing our doubles, and then we'll get started with our word problems. Are you ready? I'm going to be listening to see if you sing along with us.
Doubles, I can add doubles. It's no trouble for me to add doubles. Doubles, I can add doubles. It's no trouble for me to add doubles. 1 plus 1 equals 2. 2 plus 2 equals 4. 3 plus 3 equals 6. 4 plus 4 equals 8. 5 plus 5 equals 10. Doubles, I can add doubles. It's no trouble for me to add doubles. I can add doubles. It's no trouble for me to add doubles.
I'm listening for you to be singing.
6 plus 6 equals 12. 7 plus 7 equals 14. 8 plus 8 equals 16. 9 plus 9 equals 18. 10 plus 10 equals 20. Double up. Doubles, I can add doubles. It's no trouble for me to add doubles. I can add doubles. It's no trouble for me to add doubles.
Great job, guys. We'll not visit that again before the end of our lesson. Let's go ahead and get started with our word problems using our doubles facts. For this activity, you are going to need a piece of paper or your whiteboard, along with your materials such as counters, cubes, part hole mats, number bonds, anything that you normally bring to the math carpet. Go ahead and gather your things, press pause, and when you're ready, hit play. Okay guys, you've had time to gather your things together. Let's go ahead and get started with our first word problem. A pet shop had 7 puppies and 7 kittens for sale. How many pets did they have for sale? Let's think that one through. Remember, when we have a story problem, we always want to make sense of the problem. So let's listen one more time. A pet shop had 7 puppies and 7 kittens for sale. How many pets did they have for sale? Let's think about what we would need to do to solve that problem. What I know in the problem, I know they had 7 puppies. I also know that they had 7 kittens. They had 7 puppies and 7 kittens. How many pets are they having for sale? So I hear this 7 and I hear this 7. And I want to know how many in all they have for sale. I know that this is a part, and I'm trying to find out my whole. What equation would go best to help me solve this? On your paper, Go ahead and write the equation that you think would help us solve this. Press pause, and when you're ready, hit play. All right, guys, so let's think about that. There were 7 puppies and 7 kittens for sale. How many in all did they have? I saw some great thinking. Since we know that 7 is a part, and that's our puppies, so I'm going to go ahead and label that. I know 7 is our other part, and that's our kittens, so I'm going to label that too, so I know what they are. What I want to know is how many pets they have in all. Using your manipulatives and your toolkits, show me a model that would help you solve this problem. 7 puppies plus 7 kittens equals how many pets in all? Pause the video, and when you're ready, we'll get started. I heard some wonderful thinking and some great models came up. I'm going to go ahead and show you some of the models that I've heard. One of the models that I heard was a counting on strategy. I heard someone say 7, and then they counted on 7 more. So I'm going to go ahead and draw out those 7 more. Would you count on with me? 7, 8, 9, 10, 11, 12, 13, 14. So 7 and 7 more equals, that's right, it equals 14. And that is one of the doubles facts that we've learned. I saw some many other strategies. Let's go ahead and check some of them out too. I saw someone use a 10 frame. Remember when we draw our 10 frame, we do our box and we slice it in half. So I have my 10 frame. I saw that they put 7, and then they needed to add 7 more. But what I noticed is they ran out of room on their 10 frame. So does that mean they're done? No, because they only got to 3. They just keep going. So here's 3, 4, 5, 6, 7. So, I know that a 10 frame is full here. How many can fit in a 10 frame? You're right, only 10. So they had a group of 10 and 4 more. And I know that 10, 11, 12, 13, 14. So that gave them the same answer, 14. When you run out of room on your 10 frame, you just keep going underneath it. So I see that they made a group of 10 and had 4 more. So 10 plus 4 more is 14. That made our 7 and 7. But I saw someone else use one of my favorite strategies and models. They used a number line. And when we're using a number line, we want to make sure not to crowd our numbers, because when we put them too close together, sometimes we make a mistake when we're doing our hops, and that can mess up our math. So, I had 7 puppies, so I think that's where I'm going to start. I'm going to start at 7. And then I had 7 kittens, so I need to go 7 more hops. So 7, 1, 2, 3, 4, 5, 6, 7. And I'm going to label that plus 7. So 7 plus 7 was 14. Another strategy that was great for this could have been a number bond. Do I know the whole? No, that's what I was trying to figure out. So I know these were 7 puppies, and these were 7 kittens. And if I know my doubles facts, then 7 and 7 make 14. That's the same thing with a part-part whole. I know my 2 parts go together to make my whole. I knew there were 7 puppies and 7 kittens. And I know 7 plus 7 equals 14. Great job, mathematicians. Go ahead and get ready for your next problem. So, this problem looks a little bit more tricky. Let's see if we can figure it out. Jake had 10 shirts in his closet. 5 shirts were white, but the rest were gray. How many shirts were gray? Let's think carefully about this type of problem. Let's make sense of it. Let's go back and look for some clues. Jake had 10 shirts in his closet. I think I heard a clue. How many shirts did he have in his closet? You're right, he had 10. So 10 shirts. 5 shirts were white. That's another clue. So how many were white? 5. And the rest were gray. Oh, I remember when we learned about solving problems with missing atoms, and it said the rest or some, we didn't know how much that was, so we always put a box around it. So Jake had 10 shirts, 5 were white, the rest were gray. If he had 10 shirts, are they adding more shirts? No, so 10 was my whole. 5 shirts were white. So there were 10 shirts, 5 were white, the rest were gray. So that tells me that 5 is a part, and this mystery number is the other part. On your paper, knowing that we have our whole, 1 part, and 1 part we need, what equation could we write to help us solve this problem? Go ahead and write your equation, pause the video. When you're ready, hit play. So thinking about our problem, what equation could we use to help us solve it? I know this is my whole and that's my part that I know. I know that a whole can minus a part to get the other part. So we have our whole minus a part equals the other part. I also know that my 2 parts go together to make our whole. So I know that we had 5 that were white plus the sum that were gray equaled 10 shirts in his closet. Let's think about how we could solve that with a model. Pause the video, use your manipulatives if you need them, or draw it out on your paper. How could you solve 10 minus 5 equals box, or 5 plus box equals 10? Take a moment. I heard some great thinking. So one thing that I heard someone use was a part whole. That's a great model to use with these kinds of problems because there's a part that I don't know. I know that 10 was my whole, so I'm going to put it right down here. I know the part that I know is 5 because 5 were white. What I don't know is how many were gray. I know I can use my counting on strategy to help me solve that. I know I'm going to end with 10, but I'm starting with 5. So count on with me. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So 5 plus 5 equals 10. I also know that 10 minus 5 equals my 5 that we just found. Let's look at a different model. I can use a number line to help me with this as well. If I have my number line, I can show one or both of these problems. I know that if I had 10, I can count back 5. 3, 4, 5. And that would leave me with 5. So 10 minus 5 equals 5. I also know that if I have 5, and I'm going to end with 10, I can count up to see how many I need. 1, 2, 3, 4, 5. So 5 plus 5 equals 10. Ooh, I saw someone use their counters. I saw someone say there were 5 and those were white. And I knew that they needed to get to 10, so they counted on. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So there were 5 that were gray. You could also show it this way. You knew that there were 10 shirts. There's my 10 shirts. And I know that 5 are white. So I'm going to go ahead and color those in. So how many were left to be gray? 1, 2, 3, 4, 5. These are all some of the models that you could use to help you solve. Part whole is great when you're having a missing atom because you can see your relationships between the addition and the subtraction, because a part plus a part equals your whole, or your whole minus a part equals your other part. We used our double stacks and what we knew about those today to help us solve this problem. You knew that 5 plus 5 equals 10, so 10 minus 5 equals 5. Great thinking today, mathematicians. We have been doing such a great job with doubles. I want you to continue to work on your fact fluency and keep building those skills. I'll see you next time. Have a good day.